Alright guys, so in this video we're going to be tackling what's known, or what we're going to be seeing, of quadratic word problems. Okay, so remember, how do you even know you have a quadratic in front of you? Okay, remember, right, it's if you have an equation where something, the highest exponent in your equation is something squared. Okay, something to the second power. That's how you know you have a quadratic. Again, I think the hardest part about word problems for students is that it's kind of hard to determine how do you start or what do you do. So, yes, again, we've given it away that this is a quadratic word problem, but you need to be able to understand, okay, I see something squared, I'm going to have to go ahead and apply all the quadratic stuff that I know how to do. Okay? So let's look at the first problem here and see if this makes sense to us. Okay. We're going to fence in a rectangular field, and we know that for some reason we want the field to have an enclosed area of 75 feet squared. Okay, so we know that the area we want is 75 feet. We also know that we want the width of the field to be 3 feet longer than the length of the field. What are the dimensions of the field? Okay, so sometimes the best way to start it is to draw a picture. So I'm going to draw a rectangle. Okay. Now off to the side here, because I'm dealing with a rectangle, I saw the word area. What is the area of a rectangle again? Right, it's length times width. Alright, so let's just keep that in mind here. Now, as long as we know the two, we can just multiply it and solve, correct? So the length here, let's see, does it tell us anything about the length? We also know that we want the width of the field to be 3 feet longer than the length of the... Okay, what is the length? I don't even see it, do you? No, I'm just going to call that x then, because it doesn't even tell me anything about the length. Okay, but it does tell me some stuff about the width. Okay, it says here that we also know that we want the width of the field to be 3 feet longer than the length. Okay, so 3 feet longer than the width is 3 feet longer than the length is going to be x plus 3. Okay? Longer than is sort of the same thing as saying more than, which is why we're adding here. Okay? Now, that's all good and stuff, but we want to know here what are the dimensions of the field. So if I took the length and multiplied it by the width, I should get the area. And they actually tell you what the area is. What is the area? Right, it's 75. So if I take x, length, and multiply that by the width, x plus 3, I should get 75. Okay? But remember, that's not really what I'm looking for here. What I'm looking for here are the dimensions. What exactly are these two numbers here? Okay, so let's clean this up and see if we can come up with some conclusions here. So we've got here x times x, which is x squared. X times 3 is 3x. And that's equal to 75. All right, now, what do you see here? I see a quadratic. And how do you know you have a quadratic again? Because of the squared here. Okay? Now remember, the number one rule with a quadratic is in order to solve, you have to make sure that it's set equal to 0. Here it's set equal to 75. So I'm going to have to move that guy over there. So by subtracting 75. Okay, so I have here x squared plus 3x minus 75 is equal to 0. Okay, and then how do you solve a quadratic? Okay, right, by using the quadratic formula. You could attempt to factor this if you want. Not everything is going to factor nicely though. So, and you do know that a foolproof way of solving any quadratic is to quadratic formula it. Okay, because if you do that, then you're good to go. Now I'm running out of room here, so I'm going to switch over to a board real quick and solve this with you. Okay, so we've got here x squared plus 3x minus 75 is equal to 0. Now remember, the easiest way to do this is to label your variables. So a is going to be 1, b will be equal to 3, and c will be equal to negative 75. Okay. Now, what is the quadratic formula again? I know you remember this now. Hopefully it's been drilled at this point, but it's negative b plus or minus square root b squared minus 4ac all over 2a. Okay? And now it's just a matter of just carefully plugging in your numbers. And anytime that you make a substitution, I always use parentheses. It kind of just saves me some hassle here, if you will. Now, the opposite of b, so I've got negative times a 3 plus or minus the square root of b again, so that's 3 squared minus 4 times a, which is 1, times c, which is negative 75. All over 2 times 1. Okay. All I've done here is made simple substitutions here for a, b, and c. Okay. Now let's continue to clean up. We need to clean up the outside, the inside of the square root, and the bottom. So the outside piece here, negative times 3 is just negative 3, plus or minus the square root of something. So let's go ahead and type that in and see what we get. 4 times 1 times negative 75. And I get the square root of 309 all over 2. Okay? Now, you want to clean this up. You want to say that this is, because you're going to get how many answers here? 2, because of the plus and the minus. So you're going to say negative 3 plus the square root of 309 divided by 2, and negative 3 minus square root of 309 all over 2. Okay, so let's get our two solutions here. This will be the plus one, this will be the minus. So the plus, let's see, negative 3 plus the square root of 309 divided by 2 gives us approximately 7.28, which is fine. It's okay to get decimals here. Okay, and then the negative case here, we've got negative 3 minus the square root of 309 all over 2. And we get negative 10.28. Okay, now let's think about this for a second now, if you will. Okay, we are talking about measuring something. We're talking about building a fence, guys. We're talking everyday life now. Some of your family members may be in charge of building a fence. Okay, look at these two answers that we got here, what the possible value of x could be. If we're talking about measurements and we're talking about building something here, is it possible to have a negative length or a negative width? Does that even make sense? I'm not even sure if that was a correct sentence or not. Okay? But you cannot have a negative measurement. There's no such thing as that. So yes, you did get two answers, but does this answer make sense in terms of the problem? No. So that's all you do. You kind of just throw it off to the side. You discard it for a moment, if you will. Okay? Now, can you have a measurement of 7.28 feet? Yeah, sure, absolutely. So this is going to be the value of x that we're going to use. Okay? So let's go back to our rectangle here for a moment, because now we know the value of x. We know that the value of x is equal to 7.28. So if you want the area of this thing now, you want the dimensions. What are the dimensions of the field? Wherever you see an x, you're just going to replace that with 7.28. Okay, so here's an x. So this length right here is 7.28. And then here's another x. So replace that with a 7.28. And 7.28 plus 3 gives you 10.28. So that is the dimensions. Your length is 7.28, so that is your length.